Let us solve the number of walks for a queen, king, knight and bishop in 2x2 and 3x3 board respectively. In 2x2 board, a queen can move in 3 different ways in each and every square. So q of n is nothing but 3 power n. Same, for a king also moves the same way as a queen. So kn is also 3 power n. And for a bishop, it can only move 1. So bishop of n is nothing but 1 power n, which is 1. And for a knight, well, knight cannot move, so knight is just 0. We have done 2x2. Now let's move to 3x3. Three different squares we have, and from the corner you have 6 different ways. So q1 of, and from the edge also you have again 6 different ways. From the center you have 8 different ways. So you have q1 of n as 3 q1 n minus 1 plus 2 q2 n minus 1 plus q3 n minus 1. q2 of n, well, so again 2 q1 n minus 1 plus 3 q2 n minus 1 plus q3 n minus 1. And q3 of n, well, it's q1 4 q1 n minus 1 plus 4 q2 n minus 1. Now let's look at these equations again. q1 is the number of ways a queen can move from the corner in n moves. q2, number of ways a queen can move starting from the edge to anywhere in the board. q3, starting from the center. Well, q1, there are 3 corners it moves in one move and 2 edges. For q2, 3 times in the edges and twice in the corners. And q3, there are 4 edges and 4 corners. So 4 and 4, 8 moves. Now let's take qa of n as just q1 plus q2 by 2 of n, and qb of n as just q3 of n. You will simply get qa of n as nothing but 5 times qa n minus 1 plus qb n minus 1, and qb of n as 8 times qa of n minus 1. Now how did you do this? Now, well, just find q1 plus q2 by 2 of n. It's nothing but 3q1 plus 2q1 n minus 1 plus 2q2 plus q3q2 n minus 1 plus 2 q3 n minus 1 by 2, which is nothing but 5 q1 so qa of n is nothing but 5 times q of qa n minus 1 plus q3 n minus 1. So qa and qb of n is nothing but 5 1 8 0. Since q1 of 0 and qa of 0 and qb of 0 is also 1. We get the eigenvalues as root 57 plus 5 by 2 and minus of root 57 minus 5 by 2. The largest eigenvalue is this, so we get qa and qb of n as some constant vector times root 57 plus 5 by 2 power n, which is nothing but some constant vector times 6.2749 power n. Now let's look at the king. Where the king moves in 3, 5 and 8 respectively. So you get k1 of n as 2k2 plus k3, k2 of n as 2k1 plus 2k2 plus k3, minus 1, k3 of n as 4k1 plus 4k2 of n minus 1. So k1 plus k1, k2, k3 of n is nothing but 0, 2, 1, 2, 2, 1, 4, 4, 0 power n times 1, 1, 1. The eigenvalues of this matrix is minus 2, 2 root 2 plus 2 and 2 minus 2 root 2. So one can write k1 and 2 plus 2 root 2 is approximately 4.8284. So k1, k2, k3 of n can be approximately written as some constant vector times 4.8284 power n. Since one can write any matrix power n as a linear combination of the exponents of the eigenvalues. If, for example, you have a matrix A power n, ijth element of A power n can be written as summation alpha I lambda I power n, where lambda i's are the eigenvalues of A. Every entry is simply a linear combination of the eigenvalues. And since the eigenvalue with the largest magnitude dominates the remaining, one can take the lambda max common power n and you get alpha r lambda r by lambda max power n, and since n gets larger, this term gets close to 0. Let me write that properly. If there are k eigenvalues where ijth element of A power n is r equals 0 to k alpha r lambda r power n. This is your ijth element, and one can write this as lambda max power n times the following. So if r equal to j, you get the lambda max. Lambda j is lambda max. You get a power n ijth element is approximately lambda j alpha j. So the matrix A power n is simply can be approximated as A by lambda max power 100 times lambda max power n. So every element is just a constant times lambda max power n. Finding the largest eigenvalue will give you the estimate Finding the nth power of the largest eigenvalue will give you the estimate answer for any matrix, nth power of the matrix. So we have found for a king and a queen in a 3x3, for a knight, well, a knight, it moves in two different ways, here and here as well. It moves in two different ways, from the corner as well as the edge. So therefore knight moves in 2 power n ways for every n moves. In the corner, it moves in two of the 4 edges, and in the edge it moves in 2 of the 4 corners. But this is if it's in the edge of the corner. Otherwise, kn of n is 0 if it's in the center. Since there is no L shape in the center, so knight has 0 ways to move from the center, but if it's in the edge or in the corner, then it has 2 power n ways to move in n moves. For a bishop, you have 2 different scenarios: when it's in the edge and when it's not in the edge. When it's in the edge, when it's in the corner, you have b1 and b3 in the center and b2 in the edge. So let's compute b2. Every edge, there are 2 ways for a bishop to move. So b2 of n is nothing but 2 power n. For b1, well, it's nothing but b1 plus b3 power of n minus 1. b1 of n is nothing but b1 of n minus 1 plus b3 of n minus 1. Since there are 2 ways to move from the corner. And from the center, it's nothing but you can move in all 4 corners, so that's 4 b1 and minus 1. So b1 b3 of n is nothing but 1 1 4 0. The eigenvalues are root 17 plus 1 by 2 and root 17 1 minus root 17 by 2. So it's approximately constant times 2.56155 power n. b1 and b2 is approximately 2 constant times 2.5611155 power n, since that's the eigenvalue of 1140.